debugging the fuzzy logic application. It's a problem that I spent several hours on. Still doesn't work. How many prompts so far? Yep. It feels like 100. Ah, no, okay, that makes sense because we started a new chat as well. If I keep this microphone on, it will just keep transcribing live. Then I also can tell if I said it correctly or not. It's probably if the robot doesn't understand, no one else can. Clear. That works. Clear. You can really have a chat, continuous chat, especially if we turn on this GPT voice control. It works pretty well. Clear. Can you clear the Can you clear the last prompt? Yep.
I'm unable to edit or delete previous prompts or responses in our conversation. However, if there's any specific information or part of our discussion that you'd like to revisit or clarify, please let me know, and I'll be happy to assist further.
Right, because before I was actually going back and modifying the prompts to take a different direction, but probably don't have to do it, do we? Yep.
No, you don't necessarily have to go back and modify previous prompts. You can simply continue the conversation by providing new directions, clarifications, or additional information in your subsequent messages. I'm here to adapt to the evolving context and respond to your current inquiries or requirements based on the latest information you provide. If there's a new direction you'd like to take or a different topic you want to explore, feel free to just mention it in your next prompt.
That's great. So we tried to troubleshoot this fuzzy logic Flask application. I did provide the HTML, JavaScript, and Python code above. I'm still getting errors. There seems to be a mismatch between what the backend is provided and what JavaScript is expecting in terms of the names of the different components. Yep.
To resolve the issue where there seems to be a mismatch between what your Flask backend is providing and what your JavaScript frontend expects, follow these steps. Consistency in data structure. Ensure that the data structure of the JSON response from your Flask backend matches exactly what your JavaScript frontend is expecting. This includes property names, data types, and the structure of nested objects or arrays. In your Flask route, analyze, make sure that the response you're sending back is properly structured as JSON. Use JS-onify from Flask to ensure correct formatting. For instance, Python copycode return JS-onify, result. Make sure all the keys in the result dictionary match what your JavaScript code is looking for. In your JavaScript code, particularly where you process the response of the fetch request, ensure you are accessing the properties correctly. For example, JavaScript copycode, then, data equals greater than. Console.log, data. Other processing. Closing curly bracket, closing parenthesis. Check if the property names used in JavaScript, like data, noisy signal, data, detection error history, etc. Exactly match those in the Python response. Use console.log in JavaScript to print the data received from the backend. This will help you see if the data is structured as you expect. Use your browser's developer tools, typically F12 key, and go to the Network tab. Trigger the request and inspect the response from the server. This will show you the exact structure of the JSON being returned, which can be very helpful in identifying discrepancies. Ensure correct routes and methods. Double check that your JavaScript fetch request is calling the correct Flask route with the correct HTTP method, get, post, etc. Improve error handling in your Flask application to catch and log errors. This can provide more insight into any issues occurring server-side. Make sure that the types of data being sent from Flask, like integers, floats, lists, are what your JavaScript expects. JavaScript is very flexible with data types, but this can sometimes lead to unexpected issues. By systematically going through these steps, you should be able to identify where the mismatch is occurring and resolve it. If you're still encountering issues, feel free to share the specific error messages or behaviors you're observing, and I can provide more targeted advice.
This potentially can be addressed by Copilot. Wait, I forgot to share this. Yes, so if we're using just save that. Getting the, I don't know if it's a Linux thing. You have to do Control-Shift-C. Instead of just Control-C. Yeah, why am I not getting specific? Suggesting to use traceback. That's probably not a bad idea. Traceback and then analyze. Try existing code. When we have the exception, give us more details. give us the trace back. Control Shift C, not Control C. I have to select the whole code so it actually sends it to the Copilot. It's almost 300 lines of code. Fuzzy fuzz. Okay, no specific suggestions. Suggesting to normalize. Yeah, that should be a standard normalization thing. But how will it affect the length? Yeah, it might be correct in the fuzz logic function where you're creating trapezoidal membership, calculating membership function. Problem could be the symmetry and shadow are not the same range. Yes, but this will. Didn't this normalize? Wait, we don't have. This normalize the y-axis. Wouldn't this normalize the y-axis, whereas the problem is the x-axis, the length of the array? So the membership function should be defined over the same range as the input signal. The problem facing is related to the x-axis. The length of the signal, I need to adjust the code to handle that. For example, if the signal you're analyzing not all the same length, to resample. Can we print length of aggregated? Yes, it's aggregated. Actually call it. Okay, why the float? Ctrl-Shift-C, select the whole code. Well, right, that's the problem. Okay, that is just one. Yeah, let's pop it into HTTP as well.
The error message in the stack trace is pointing towards the fuzz. Defuzz function call in your fuzzy underscore logic function. Specifically, it's saying that the lengths of symmetry underscore universe and aggregated must be identical. Let's address this. Check the lengths of symmetry underscore universe and aggregated, based. Based on your print statements, symmetry underscore universe is correctly defined and has a length of 100. However, the aggregated value seems to be a single scalar, 0.038618259312655724, instead of an array. The aggregated variable is expected to be an array with the same length as symmetry underscore universe. It represents the combined fuzzy set resulting from the application of your fuzzy rules. Go back to where aggregated is being calculated in your fuzzy underscore logic function. It seems that aggregated should be the result of combining multiple fuzzy sets, like rule underscore square, rule underscore triangle, rule underscore trapezoid, typically using a function like np, fmax. Ensure that this combination results in an array, not a scalar. If aggregated is currently being calculated as a scalar, you need to modify this logic to create an array. For example, if you have multiple rule outputs, e.g., rule underscore square, rule underscore triangle, you should aggregate them using np, fmax across each point in the universe. Python copy code aggregated equals np, fmax, rule underscore square, rule underscore triangle. Aggregated equals np, fmax, aggregated, rule underscore trapezoid, hash if you have more rules. Recalculate the centroid. Once aggregated is correctly an array of the same length as symmetry underscore universe, you can then use fuzz, defuzz to calculate the centroid, Python copy code centroid equals fuzz, defuzz, symmetry underscore universe, aggregated, centroid. By ensuring that aggregated is an array that correctly represents the combined membership after applying your fuzzy rules, and by having it match the length of symmetry underscore universe, the fuzz, defuzz function should work as expected. This should resolve the assertion error you're encountering. The issue seems to persist because aggregated is still a single scalar value instead of an array, as required by fuzz, defuzz. This mismatch in length with symmetry underscore universe is causing the assertion error. The aggregated variable should be an array representing the combined fuzzy set after applying all your fuzzy rules. It appears that in your code, aggregated is being assigned the value of rule underscore square, which is just a scalar in this case. You need to ensure aggregated is an array of the same length as symmetry underscore universe. Here's what you should check and modify. Ensure all rules are arrays. Make sure that rule underscore square, rule underscore triangle, and rule underscore trapezoid are arrays of the same length as symmetry underscore universe. Each of these arrays should represent the degree of membership for each point in the universe after applying the respective rule. Use np, fmax or a similar function to combine these rule arrays into a single aggregated array. For example, Python copy code aggregated equals np, fmax, rule underscore square, rule underscore triangle. Aggregated equals np, fmax, aggregated, rule underscore trapezoid, hash combine with more rules if needed. This will create an aggregated array that is a combination of all your rules and has the same length as your universe arrays. Now that aggregated is an array of the correct length, use fuzz, defuzz to calculate the centroid. Python copy code centroid equals fuzz, defuzz, symmetry underscore universe, aggregated, centroid. By ensuring that aggregated is an array representing the combined membership values over the symmetry underscore universe, you should be able to resolve the error and successfully calculate the centroid. This aggregated array needs to represent the overall membership value at each point in the universe, derived from all the fuzzy rules you have defined. By ensuring that aggregated is an array representing the combined membership values over the symmetry underscore universe, you should be able to resolve the error and successfully calculate the centroid. This aggregated array needs to represent the overall membership value at each point in the universe, derived from all the fuzzy rules you have defined.
Yeah, obviously just resizing would not work. It's better than what we currently have. It's actually working. That must be fake. Come, this is changing at all if this centroid is not moving. No, this is not right. This is not right. Noise amplitude is 0. Oh, come on. Should be all orange. How do you actually GPT-4? Do you make any
Correct.
suggestion?
For your fuzzy logic implementation to work properly, rule_square, rule_triangle, and rule_trapezoid need to be arrays where each element corresponds to the degree of membership at each point in your symmetry_universe array. Here's a breakdown of what to do. Create rule arrays, each rule array, rule_square, rule_triangle, rule_trapezoid, should be created based on your fuzzy logic conditions. They should be the same length as the symmetry_universe. These arrays are typically created using fuzzy logic operations, like fuzz, interp_membership, which will yield an array of membership values for each rule based on the input fuzzy sets. Rule array example. For instance, if rule_square is meant to represent a condition where the signal is considered a square wave, you would use fuzzy logic operations to calculate the degree of membership for this rule at each point in your universe. This will give you an array of membership values that correspond to how much each point in the universe satisfies the square rule. The aggregated array is a combination of these rule arrays. You combine them using operations like np, fmax, which will take the maximum value at each point across all rules. This might look like Python copy code aggregated equals np, fmax, rule_square, rule_triangle. Aggregated equals np, fmax, aggregated, rule_trapezoid. After this operation, aggregated should be an array where each element is the highest degree of membership across all rules at that point in the universe. Its length should match that of symmetry_universe. With aggregated correctly formed as an array, you can then pass it to fuzz, defuzz along with symmetry_universe to find the centroid. This operation will give you the defuzzified output based on your fuzzy logic system. By following these steps, you ensure that your fuzzy logic system is working with arrays of consistent lengths, allowing for the correct application of fuzzy operations and defuzzification.
Load the this is the updated Python code. It doesn't work as expected. As expected. This is the Python code. It doesn't work as expected, and it doesn't produce any errors. Yep.
Your Python code for the Flask application and the fuzzy logic implementation appears to be well structured, but there are a few areas we can review and potentially improve to help resolve the issues you're facing. Check for consistent lengths in fuzzy logic arrays. You've added print statements to verify the lengths of arrays like mf_symmetry_low, symmetry_universe, and the rule arrays. This is good for debugging. However, the print statement showing aggregated still indicates it is a scalar value, not an array. This is likely the root cause of your issues. Ensure that aggregated is definitely an array with the same length as symmetry_universe. The correct aggregation should be done using NP, fmax across the rule arrays, as you've done in your code. But verify if rule_square, rule_triangle, and rule_trapezoid are indeed arrays and not scalars. The way you're using NP, fmin and NP, fmax should result in array outputs if the inputs are arrays. Double-check the values of rule_square, rule_triangle, and rule_trapezoid before they're aggregated. They should be arrays representing the activation level of each rule at each point in your universe. Review the analyze_signal function to ensure it's correctly handling the outputs from fuzzy_logic. It should receive an array for aggregated and a scalar for centroid. Make sure that all data types throughout your functions are as expected. For example, symmetry and sharpness should be scalars, and all your fuzzy logic arrays should be numpy arrays of consistent length. If the backend seems to be working correctly, as per your debugging prints, the issue might lie in how the front-end JavaScript code is handling the received data. Ensure that the keys and data structure of the JSON object sent from Flask match what your JavaScript code expects. Verify that the analyze route is correctly handling the request and response. Make sure all data sent in the JSON response can be serialized properly. Good job on adding traceback, format_xe, for better error logging. Make sure to check your Flask server logs for any hidden errors or warnings that might not be immediately obvious. Ensure that the front end is correctly making requests for back end and that the back end is receiving the correct data. Inspect the requests and responses using your browser's developer tools. By thoroughly checking these aspects, you should be able to analyze back
For decimal numbers, can we only keep 2 digits after the decimal point? there are a couple of things. First of all, we would like to limit the number of digits after the decimal point to 3. Also would like to know why the rule square array has all the same numbers. Yep. Let's start with that. Let's start with that. Clear.
You can limit the number of digits after the decimal point by rounding the values in your arrays. In Python, this can be achieved using the NumPy library, which provides a convenient function called NumPy, round. Here's how you can apply it. If the rule underscore square array has the same number repeated throughout, it suggests that the logic used to compute it is resulting in a uniform value for each point in your symmetry underscore universe. Here are a few things to check. Rule conditions. Ensure that the conditions used to compute rule underscore square are correct. Rule underscore square is obtained by taking the minimum, NP, FMIN, between symmetry underscore high and sharpness underscore mid. If either of these arrays has uniform values, or if the conditions for these rules are too strict or too broad, it could result in a uniform rule underscore square. Input signal characteristics. If the input signal has characteristics that strongly match or don't match the conditions for being a square wave, as defined in your fuzzy logic, this could also result in uniform values. Check if the input signal is varying as expected and not producing repetitive or overly consistent patterns.
Round to 3 digits. AMF low. Come wrong, that shouldn't take a signal, noisy signal. A signal is potentially incorrect. Yeah, so that should be a local variable. A variable called signal, is it potentially conflicting throughout the code in terms of its name? The signal. Should not matter, but we just want to change the names for consistency's sake. We have to continue this another time because we stuffed something up. Yeah, it's really easy to blame the board for it, but noise amplitude doesn't go to 0. What? We would like for it to go to 0 as it used to. Interestingly, detection error is 99%. How's it 99%? So that the GPT has the updated code.
It seems like you've updated your code to round the waveform data to 3 decimal places, which is good. Regarding your question about why the roll_square array has the same numbers, let's delve into a few potential reasons.
First of all, how to make sure all the variables in the code are rounded to 3 decimal places. Yep. Using round. Yeah, not be round.
In your fuzzy underscore logic function, round the outputs of each calculation. This includes membership values, rule activations, and the aggregated result. Round the final outputs of your fuzzy logic, such as the centroid. For any other calculations in your code, such as symmetry, sharpness, detection error, and unknown percentage, apply rounding as well. If you have NumPy arrays containing multiple values, e.g., noisy underscore waveform, symmetry underscore universe, rounding as shown above will apply the rounding to each element in the array. By applying rounding consistently across your code, you ensure that all variables are limited to 3 decimal places. This approach helps maintain uniform precision throughout your calculations, which can be particularly important in scientific and engineering applications.
You have to add that last bit, that last sentence. So the question is, can I just by default round the... Can I just round everything by default instead of rounding each variable individually? Yep.
Rounding every value in your code by default, without individually specifying where to round, is not directly supported by Python or NumPy in a global sense. Python and NumPy do not have a built-in feature to set a global precision for all floating point operations. This is mainly because in scientific computing, it's often important to control the precision at specific points in the computation to maintain accuracy and prevent rounding errors from propagating.
Should be up to the developer.
However, here are a couple of approaches you could consider. Custom wrapper functions. Create wrapper functions for operations where you need rounding. These functions would perform the operation and then round the result. Manual rounding at strategic points. Continue rounding manually at points in your code where the precision matters, such as after a series of calculations or before outputting results. Display precision. If your concern is primarily with how numbers are displayed, rather than the internal precision of calculations, you should adjust the print display settings in NumPy.
That's interesting.
This will not change how numbers are stored or the precision of calculations, but it will affect how arrays are printed or displayed.
So where do I do this? That didn't work. That didn't work. Bye.
If the rounding is mainly important for output, e.g., sending data to front-end or saving to a file, you should round the data at the point of output instead of throughout your calculations. Ultimately, the choice of where and how to round will depend on the specifics of your application and where precision is most critical. For most scientific and engineering applications, rounding is applied at specific points where the level of precision is known to be sufficient for the accuracy of the results.
Round all variables. Oops. I turn the microphone on here. Round all variables to 3 decimal points. Clear. It's actually doing it. Changed 10 lines. It keeps counting the number of lines it changed. 10, 9, 10, 9. What? Ooh, CPU really going. Okay, it made a lot of changes. No, no. Round symmetry. Did it add a function? Okay, now I'm a bit confused. When they are generated. Generated and initiated could be different things. Suggesting to delete all that. Yeah, no, it's going places. It's not right, is it? I just got rid. Aggregated symmetry universe. Noisy waveform. Then AMF low. So converting it to least. Where are we printing fuzzy data? these values. Control I, limit to 3 decimal points. Why are you doing it differently? Does it matter how many lines I select or what? Right. Yeah, obviously that bit is wrong because it's just probably padding with zeros or something. Yeah, this is a mystery why sometimes it's generating. Yeah, okay. I don't mind which one is it, just adding extra lines, that's okay. Clear it first. Okay, this is better. Where are we printing noisy waveform? We're rounding it down. Okay, I might have to continue next time. See you in a bit. Bye.